And we're live. So, welcome everyone to the first episode of the Astra interview series, where we're going to explore space one idea at a time. So, today we're thrilled to have with us Kacper Lecki, a computational physics researcher, aerospace engineer, and the founder of Aerolympic, currently working on cutting edge technologies and shaping the future of flight. He holds a master's in aerospace engineering from TU Delft, Europe's number one university for aerospace, by the way. He's also someone I've personally learned a lot from, especially about the fascinating realities that aerospace has to offer. Casper, we're absolutely thrilled to have you.
Thanks for having me, and hello, everyone.
Today, we're just going to be looking at some of the new things in space, what's happening, what's new in space, why is it so interesting all of a sudden, what are some crazy technologies of space that are coming up, how sustainable can we actually make space exploration, and just the future of space in general. So let's kind of set the stage here. Like, we see aerospace is a lot more mainstream now. Everyone's talking about aerospace. There's definitely been a lift in the industry, I would say, and everyone's ready for aerospace to be the next big wave. What are your thoughts on this?
Yeah, definitely. All cutting edge technology, like all transportation systems, started out very niche. First, cars were extremely niche things. Then they get extreme popularity. Uh, then we have aircraft. First flight in beginning of 20th century. Now most of the people have flown on the aircraft. Still, it's created by big companies and coming down to more personal aviation as times go on. So probably the same thing will happen with space, right? It started with just a few space agencies across the world, and now we have bigger companies coming up, setting the stage. Maybe at some point each of us will have their own personal rockets to move across the globe faster.
Yeah, I mean, it's kind of crazy to see how like these new like moonshot ideas they just get introduced into human society and then it just slowly becomes so normal and we can kind of see it and that's the cool thing with space. We're seeing it happening. We're seeing space become more inclusive, more accessible to everybody. And that's kind of what we're aiming to do at Astra as well, making space accessible to everyone.
Yeah,
But
it's very often there is some social pressure as well. Right? The social effects are very important in making things more
yeah.
accessible because new technologies tend to be scary. If you're thinking about flying to the rocket, you're essentially tying yourself to the huge fuel tank mixed with oxidizer. So essentially, you're strapping yourself to a bomb. So it takes time for people to process that it actually can be safe. So that part is also very important to kind of show people that there are a ton of precautions, redundant systems, and so on. That it actually is really safe, and actually, well, space travel is now probably safer than driving in your car. So
No, I mean, that kind of revolves back to the theme. Like, humanity is always scared of the unknown. And, like, as these new things come to get discovered, it's just humanity always is very, like, skeptical about it. Like, oh, what if it doesn't work out? What if it goes wrong? Instead of, like, thinking about what if it actually goes right and the benefits it can actually have. And even in space, actually, we're kind of like seeing a huge shift. Like, before it was the space race, it's all about exploration. Who's going to get to the moon first? Who's discovering this? Who's discovering that? It's a race at first. And then suddenly we see a shift to privatization of the space industry. Like, it's not about countries anymore. It was about who's building the newest startups and what are these startups looking forward to? What are they working towards? And that's when we saw companies like SpaceX come around, them making their own path in the space industry. And now, of course, that shift is taking an even greater turn. And now we're going all the way into sustainability for space. Because the more space progresses, we're kind of seeing that it's not really the most sustainable thing, but there's obviously ways to make it more sustainable.
yeah, of course. Well, the nice thing about being sustainable, right, using less energy and less materials, is that it benefits everyone, right? For people who are manufacturing the rockets and are actually flying the rockets, less fuel use equals less cost, and it's particularly important with rockets because you actually need to carry fuel for your later journey. So
Yeah.
the more fuel you need to carry, even more fuel you need, and it increases exponentially. So if you can make it more sustainable, you benefit people who are flying because the costs get lower. Also, it allows more people to get into space flight, but also it benefits everyone else because less fuel use equals less pollution. So it's really a good goal to have. Uh, yeah.
Yeah, 100%. It's like benefiting both sides. It's benefiting the world, benefiting the consumers, and benefiting the company because it's obviously much cheaper, I'd say, for the company itself. So, yeah, it's all in all a win. So, sustainability is definitely like the next goal of space exploration. Like, it's nice to see how we're going more towards only necessity driven exploration rather than just curiosity, I would say. And especially in the space industry, like there's so much stress on the sustainability factor that it's kind of pushing boundaries of space like never before, and we're seeing new technologies, uh, new techniques coming in that were kind of unimaginable and unthinkable in the past. But like as we're progressing, as time is passing by, we're seeing so much come into play. There's so much new things happening, and it's just exciting to look at it all. Let's get into a few of them. So, I mean, first off, like the most obvious, right? So, this AI is what everyone's talking about. But now we're seeing that AI can also kind of shape the trajectory of the space industry as well. Like,
Yeah,
what?
that is pretty crazy. And the use of AI is, well, it becomes quite prominent in everyday life. Like people got into AI using chat GPTs, Geminis, editing photos with AI. And really, engineers been on this front as well for much longer. Not quite in the large language model space because that wasn't as interested because engineers are really good at talking to computers in their own language, which is called programming. Uh, so they didn't need large language models to communicate. But still, there's a huge new field growing up, especially with the advancements in GPU power uh, and creating of those data centers that grew because of the LLMs recently. But that also means that we have more power available for engineering applications. So now we can take those data centers and just even if it's a small subset, we can use those for sort of exploring what large language model would like to say. We can use it to figure out what's the best design for our rocket. Right? It may not be
Yeah.
perfect calculation if we were to figure out the aerodynamics of supersonic rocket. That's extremely complex, but AI is really good at seeing patterns. So sometimes it can tell us quite early on if a design makes sense, even to try it out in a more professional simulation. So yeah, AI is changing it at every stage, right? All the way from people talking to AI to just design exploration and figuring out what a proper rocket should be, all the way to analysis of data, right? I worked alongside a project that looked at how AI can be used to track craters on Moon. And
Oh, wow.
right, because you can take pictures of Moon, but if you were to ask some person to mark all the craters and their sizes, that's extremely time-consuming work, and time-consuming in science and engineering is extremely expensive, right? Because you need to pay people to do that. So I saw people working on how to do it by AI, right? It's just marking circles. So you can create a good algorithm which looks for pattern, which is a circle on a silver globe. Then you can automate a lot of processes. It still costs to run AI model, right? You still need to pay for electricity, but quite often it's cheaper than hiring and training human to do it.
Right. And AI isn't like, I feel like, yeah, that's a very niche use case of AI, like automation and like going through rapid iterations, like seeing for patterns. Yeah, just like the moon, like we're searching for patterns like dark circles, spotting them out. But I feel like AI is also kind of gaining its role in like the autonomy of a spacecraft. Like spacecrafts have always known to be more or less on the human control side of things, and they work more or less on their own. But we're kind of seeing people kind of envision AI kind of controlling the entire space system. As for example, I've gotten into electric propulsion a lot recently, and we're kind of seeing how AI can actually control magnetic fields and keep them at like stable values and keep them at the optimal magnitude for the best like possible thrust, especially in electric propulsion. We're also seeing how AI can, change air traffic in commercial aeroplanes, for example. It's kind of like we're giving the aeroplane its own brain, or the rocket its own brain for that matter. And it's nice to see how more than automation we can kind of use it for autonomy as well. But then again, there's like this risk factor, like what if AI makes its mistakes, right? Even in iterations. I mean, AI is useful, but at the end of the day, it's not perfect. So it could always like make these mistakes, like in patterns and also in like autonomy itself. And autonomy is like obviously a bigger risk to take because you have the entire like aircraft in the AI's control, and if the AI messes up, that's a huge loss. So
Yeah.
I feel like the fear around AI is pretty prominent.
Yeah, no, it makes sense. So we're kind of doing with AI what you usually do while raising kids. You give it a small task, like some small responsibility that if AI screws up, nothing bad will happen. And well, just as a kid, you give it a task that, like, well, if you don't wash the dishes well, nothing bad will happen, right? But as they grow and as we increase confidence in AI, we can give it more and more responsible tasks. Right? We can give it responsibility, which is tricky in places where safety is important, right? Because then you also we're going into a kind of philosophical discussion here, right? Who takes
Yeah.
accountability if something wrong happens? So currently, what is being done is you may include AI or some other control system. Right? There's whole control system theory on how to make things be stable and where you want them to be. But we apply it for small modules. Right? We don't give a rocket one big brain that controls everything. We are they divided and split it into, okay, this part of the brain takes care of just controlling the magnetic field. This part of the brain ensures that there's oxygen. And there are a bunch of safeguards in place. Right? If AI wants to do a very extreme action, there should be something in place. Right? So usually there's another program that is deterministic, so it doesn't rely on AI in any sense. Right? It's just basic controller that also can figure out if is that extreme action really necessary. And also you can have a human in the loop as well that gets notified, like, hey, AI wants to do this really extreme action. Do you think it makes sense? Because AI is really good when used in the data it's already saw, right? So if we are operating at the conditions that are close to something that I already saw, that probably will be fine. However, when you move out of the comfort zone of AI, that's when you get all the hallucinations and weird outcomes, right? Because if it sees it for the first time, it won't know. Right? If AI is trained on how to differentiate between a picture of a cat and a picture of a dog, and it gets really good at figuring out which one is which, if you show it a picture of a monkey, then it will get confused, right? So it makes sense. We start building the credibility of AI. Also, same social sigma. Right? We have more and more self-driving cars with AI included, because there's vision processing. That's the biggest AI field in the autonomous cars. And so far, people seem to use it more often than not. So I think it gets this safety factor included, and it gets trust slowly but surely.
Right. So it's like, yeah, I guess it is kind of like a kid, like small tasks build trust with it. And then we can kind of integrated more and more. And another thing is AI is not the only thing that's kind of changing this industry. Like there's obviously a whole new set of technologies and ideas involved. Like one in specific is the space debris problem. Like there's huge amounts of rockets that go up every year, and then there's a huge amount of trash they leave behind because it's just better to leave it there than to bring it back all the way to Earth. And until now, I mean, it kind of we kind of never realized the repercussions of it. Like we kind of thought space to be like this vast empty space, and then we could just leave our trash there and it would sort itself out. But then yeah, it's come to bite us back and it's kind of becoming a problem. And that's what a lot of companies are focusing now on too, like clearing all the debris, like tracking all this debris. Like there's so many new startups that are coming up just to tackle this problem specifically. And yeah, it
Right.
might be the next big thing in the space industry, like clearing up the debris before we go any further.
Yeah, so as you said, initially no one saw this as a problem, right? Because it's space, right? What's bad that can happen? Now, in mission planning, you actually take into account where things fall. So you try to, detach things that are one use somewhere at low orbit, so it burns in the atmosphere eventually. But still, things go wrong. So some things are left in the orbit, and as you said, more and more startups are coming up. It's similar thing with actually protection of environment on the ground. The very first initiatives that took place don't really get funding because people don't see the benefit. They're like, oh, it's not that bad. Right? So it's hard to convince people that it's something important because it can be much worse. So we need to take action now. Same with climate change, because the consequences are on the kind of long time horizon. The ideas tend not to get funded as they are seemed not urgent. So it's hard for those small startups. So I think it's very important to support their work. I hope at some point people realize that if we want to travel to space, we need to keep it tidy. Maybe we'll have space reserve on the low Earth orbit where it's illegal to leave trash out. Maybe we'll have startups that have the park rangers who will be able to clean it up a bit. And I hope people realize the value of the space. Right? If we pollute it too much, we won't be able to leave Earth at all. So,
No, that's right.
and you will get those streaks on astrophotography that are from human debris.
Yeah. Right. And it's having an impact on not only photography but a lot of things. Like we could even mess with the navigation of spacecraft, and it's not really the best thing to leave all our and that's a sick idea, like keeping kind of like police there just to make sure, like, oh, he left behind that trash, and then they could also go clear it up. I mean, yeah, it's a crazy concept how we can kind of convert space into like something more localized, something that we use every day, but we can kind of replicate that in space as well, like the methodology and the idea behind it. But then again, the concept of debris comes when rockets are not really reusable, like when they're supposed to, not get utilized again, just left over there. But that's where a lot of companies are, striking it down, like, oh, what if rockets are actually reusable? We don't even have to leave behind trash there. We could just bring it back to Earth, reuse the entire rocket system. And that's what a lot of companies are focusing on now. Like we have obviously SpaceX, the pioneer, and then we also have Blue Origin going more into reusable rocketry now. And it's there's everyone's pushing towards 100% reusability, and that's a crazy concept because there's so many parts of a spacecraft that are kind of one-time use, but the way we're kind of pushing it towards 100% reusability, everything gets used again, is not only sustainable, but it's kind of crazy to think about that we're moving so fast.
Yeah, actually, well, it started as a effort by NASA initially, right? That's where we had shuttles from. That was the first idea that, well,
Yeah.
maybe we can have something that comes back to Earth. And then the private sector took in, and actually the initial kickstart, I would say it was the X Prize. And it was a huge prize to compete for a spacecraft that can reach space twice in a period of 2 weeks. I think in the end it was won by Virgin Galactic, so they were actually the first one with their Spaceship One and the night aircraft. And they had an aircraft that took the rockets high up already, and then they picked up from the aircraft. Very exciting technology, and yeah, that was actually the first time we saw private companies go to space and with reusable stuff. And of course, completely different idea than what SpaceX does. And that idea was still landing like a plane. SpaceX blends rockets as rockets, which is another interesting take. And as we can see, it can work. So it's amazing. I'm curious what the next step will be, and I'm glad to see that more and we are growing towards that 100% reusability. Again, makes sense for everyone. It's cheaper, doesn't pollute the environment. Absolutely great.
Yeah, I mean, even here we're seeing like the private sector also get divided into two. Like, obviously, we have companies like Virgin Galactic that's just picking up where NASA left off. We land like a plane. We use the systems like a plane more off, and then we have obviously SpaceX. We're more focused on the vertical style of landing, which is which I would think is a lot harder. Uh, like 100% has to be, but
You're
but
coming
then
in
again,
faster. There's less margin for error.
yeah.
The only benefit is that you don't require a runway, but still, it's impressive that they can achieve that.
Yeah,
It's really crazy.
the difficulties kind of like outmatch the benefits of landing vertically, and that's crazy. Like, it's nice to see how even though there's a simpler option of landing horizontally, we're still seeing companies focus on vertical and trying to get that more normalized, get that more like utilitarian, I guess, if that's the right word, because
The, the,
obviously that
bene-
would
the,
have.
yeah, the main benefit here is that you use the stuff that you would already have on the rocket. So you don't need to have additional wings stored somewhere. You don't need to tailor your rocket to be a good aircraft as well, right? You can only focus on making a good rocket, and just tell it how to land properly on Earth. That's the hard part, but the designing of the spacecraft is actually easier, because no wings, no need to take care of creating lift and controllability in terms of traditional lifting surfaces. So there are easier parts, right? That they have benefits. Clearly, if there were no
Yeah.
benefits, they wouldn't do it. So clearly, they show
Yeah.
that this can work.
100%. And it's nice to see that even though there's an easier path, they're still focusing on that just because of the benefits it's giving. And I feel like another like sector that these companies are also focusing on is like not just the framework of the rocket itself, but they're also kind of focusing on how to create like this new propulsion technology. Because obviously the propulsion technology that we currently like use so normally, that's for small missions, we most often use chemical engines, and which is not only not sustainable, but it's like a huge amount of fuel, and then that we're just deriving from fossil fuels, and we're kind of burdening the current like reserves that we have for these fuels. And people may think of it to be a huge waste to use that for rocket exploration, like for space exploration. And that's where we're seeing these new companies develop these new technologies. Like, yeah, you have obviously this nuclear propulsion coming in. There's obviously electric propulsion, which is a lot more in use now. And but I think the issue with all of these is like they're all for mainly in space missions. Like, we're not seeing enough power on the earth, we're not seeing enough reusability like getting off from earth. And I feel like this is also going to become a huge sector of importance, because all these companies are also trying to maximize the thrust you get from electric propulsion, because currently the thrust is like very low, like it's in millinewtons. But we're seeing different types of electric thrusters coming in, like that can actually get us into the tens of hundreds of newtons range, like the MDP electric thruster I've heard. It's they're kind of pushing the boundaries to which electric propulsion can take us, and that could evolve into a whole new field of reusability, because now not only are the structural components of the rockets reusable, but we're also reusing the engine, and the fuel that we're using, the gases that we use for these propulsion is so much lesser, like probably 10% of what's already being used, so it's so much more sustainable.
Yeah, correct. It would be great if we could have electric propulsion. And as you said, the biggest disadvantage right now is the thrust, or rather the thrust to weight ratio, right? We could create a very large ionic thruster, which would have a lot of thrust. The problem is it would weigh a lot on Earth.
Yeah.
So, especially with the batteries that it would require. So yeah, hopefully at some point we'll get there, or we come up with another propulsion system. We have so many new technologies coming up. Maybe someone comes up with yet another thing, or maybe they will do what Virgin Galactic. They can figure out that, well, maybe we can create an aircraft that will bring our spacecraft further from Earth, to make it easier. We'll see. It's exciting times
100%.
to live.
Yeah, just complete new field just opening up. And also, like with all of these new scope, we're also seeing a lot more of like these ideas that really kind of sound impossible. Like I just like to pick up from where we just left off, like propulsion, right? There's this new crazy idea that's coming into this propulsion space, and it's kind of being pioneered by this company called Spin Launch. So what spin launch really does is like they just rotate a small rocket like really really fast, and it's kind of like how you use a string with a stone and then you throw the stone. So yeah, they just take the tangential path and then shoots you all the way. So it kind of takes away the entire need of acceleration. Like you need much less fuel because you already have like a certain amount of velocity, and then you just need a bit more of a push. So it's obviously a lot more sustainable than what we currently have, and it's also a sick idea. Like again, it's revolving back to the theme of taking normal things that we see every day on Earth, and then we're just replicating that in space.
Yeah, that is correct. That idea is very nice, right? Because you can accelerate slowly, right? Because it doesn't matter how long you spin for. You can use less power, and you can use that power efficiently. You can use electric motors to spin that up. So that is a great idea. Well, unfortunately, not for humans, because
Yeah,
humans wouldn't be able to sustain the G forces. But
right.
electronics doesn't really care, well, that much about G forces. It cares about vibrations, so the structural weight may be increased, but still the benefit of saving fuel is enormous. Right? You just create
Yeah.
energy on Earth. You can have, well, you can even take it from normal grid, and yeah, just try to fly high.
Yeah, and then the energy you take from Earth can obviously be renewable as well. So basically, you're having near zero environmental impact, which is obviously a great thing, especially for space exploration, which is kind of like again, like people are kind of not regarding it as very useful because of the environmental impact it has. But if we can prove it to be kind of sustainable and reusable, it's a whole new field of discovery, and we could probably gain so much out of it as well. And another crazy idea that's been popping up a lot recently, it's artificial gravity. Any idea about artificial gravity?
Yeah, so artificial gravity is actually a very simple concept, right? The, when you're on space, when you're orbiting Earth, you would normally feel gravity, but you're essentially falling off on the Earth, but you're moving forward just enough to match the curvature of the Earth. So the concept behind the artificial gravity is to have some net force acting on you. There are two ways you can, for example, keep accelerating your aircraft. So just have thrusters going on. If you have thrusters going on, you have acceleration. That's kind of like when you're accelerating in the car, you get pushed back into your seat. So that's exactly the same idea for artificial gravity. You just need to I keep
but then
accelerating. That's one
they're
thing.
they're using it at such a like probably a huge scale that it's kind of like actually serving as gravity, because obviously the car force isn't much, but I mean this the force that they're using it at can actually like take you to the base, like take you to the like point where like the force is concentrating towards.
Yeah.
And
Well,
it's
actually, apart of it, with the new electric cars, the acceleration forward can be similar to the gravitational acceleration. So actually, the forces that you get would be very similar to accelerating the fastest electric cars on Earth. The problem is that you need to keep accelerating all the time while you want to have gravity. Or have a
yeah.
second idea, which is much more common in science fiction. Have a spherical object, or well, ring-like object that rotates. Then you have essentially centrifugal force pushing you onto the outer parts. Like on the merry-go-round, you would feel a force pushing you outside. You can use that to create the artificial gravity. And the nice thing about it is that essentially doesn't cost anything, because once you start spinning, you just, especially in space, you just keep spinning. So you can essentially maintain that artificial gravity for a very long time. The challenging part is you need to build a huge ring in space and make it rotate, but and that usually outweighs the benefits of having artificial gravity. But yeah, that's another option that was present in science fiction and is actually considered today to use. Uh, it's kind of different than what people do on International Space Station, right? That they don't feel gravity, they feel weightless. So to actually to maintain some level of being in good physical shape, they actually just tie themselves to springs that would push them into the ground, so they can do squats and have some
Fair
physical
enough.
activity that wouldn't make the muscles disappear. So right now, well, we think it's quite expensive to bring things to space, so we're essentially stuck with springs. But probably as times go on, we would like to have a long-term mission for a lot of people, or for a lot of experiments where gravity would actually be important. Then we could create that ring. Or another thing where this could be used is for experiments where you would want to have varying gravity, because then if you're in a ring that rotates, the distance from the center would determine how much gravity you would have. So then you could have different samples at different gravitational strengths. So you could actually measure the quantitative effect of gravity rather than what we've been doing with experiments now. We would test things on the ground with Earth's gravity and on the International Space Station with no gravity. Right? So we don't really know what happens in between those points. But still, quite interesting to do
No,
that.
and then you can just play around with the gravity, get different tests done. That's a
Yeah.
sick concept, honestly. And even I'd say even crazier than that maybe is this idea of asteroid mining. Wow, like now you're just taking rockets and now you're just scooping materials off the asteroids, bringing them back, and then now we're selling them or we're using them. Because yeah, like a lot of the times when we do like discover asteroid debris and like these actual in space objects that like sometimes make their way onto Earth, we discover like a lot of precious elements and precious material there. And then that just has the more commercial companies thinking like, what if we don't wait for it to come to us? What if we go to it and then take the materials out, bring them back to Earth?
Yeah,
New and
that makes a
upcoming.
ton of sense, because well, we have a lot of those precious materials on Earth, and they are precious because they are scarce. Uh, but they are not necessarily inherently scarce on the level of the universe. They are scarce because we don't have much on Earth, and because of different factors. Among others, the rocks that the Earth was formed from simply didn't contain much of those rare elements. But the asteroids that can come from different places in the universe, from different places in the solar system even, they can simply bring those stuff to us somewhere closer, even if not directly to us. And those materials that are not as rare on the universe scale come to us, that we consider them precious because of different properties, or simply because they are rare. Right? That's sometimes we consider things to be worth a lot purely because there's not enough supply of them. But by going mining, we actually increase that supply, which again benefits everyone. It can benefit the companies that do the mining, but also benefits the humanity as a whole. Because, for example, we have more silicon to do more electronics from, or we have more rare earth metals to produce more batteries for cars. And also, if we have more, it means the price gets lower. It's a simple law of supply and demand. So, again, benefits everyone. It's just a matter of how much it costs to get to the asteroid, mine it there, and come back. So, the moment that cost can be offset by the revenue from asteroid mining, I'm sure there will be companies popping up and getting into that space.
Yeah, and it's the way like space is kind of making its way back into society, kind of like it's like I see it as a loop, kind of like we go to space and then somehow space kind of reverts back and kind of positively affects like society, because not only asteroid mining, which yeah, 100%, we're going to the asteroids, we're taking things back, and then we're kind of uplifting the economy and like the resources we have over here. But that's not the only place where we're seeing like this from space to society kind of a loop. We're also kind of seeing it in like these the new technologies that we talked about. For example, let's take AI in space. When we kind of go into the further integration of AI in space, we can kind of see how AI can, because it's so good at predicting patterns, it can kind of see Earth's patterns, and it can kind of predict from a bird's eye view that okay, that's a climate disaster symptom right over here. Something's going to happen over here. We can kind of have like a early detection system, and that could solve so many Earth problems, and it's just looping back all the way to society. And it's just at these intersections of different new technologies that we see that science is kind of pushing us back to society.
Yeah, I mean, space exploration is very useful for everyday person, right? I forgot how to use maps by now. Right? I use GPS with navigation to tell me where I am. The moment it stops working because of something, I get lost and I miss my off ramp and I go a few kilometers somewhere where I wasn't supposed to go. Right? GPS we have thanks to being in the space and some deeper physics with time corrections that mean to make it precise. Weather prediction, as you said, and climate changes are a huge thing in space, right? And also with AI to monitor how clouds form, where they form. We could predict much earlier that something will happen. Right? There's a tornado forming somewhere, which is huge. Like, it saves a lot of lives because people actually have time to evacuate and.
Yeah.
It's extremely important. Right? The space exploration seems useless. Right? It seems for a lot of people consider it for like, oh, well, either for just extremely rich people who want to get tourists and see Earth from outside, or for scientists who do really weird experiments in space and observe the universe. And a lot of people don't see value for humankind in those types of experiments, but actually there are huge like benefits for everyday person coming from space. And as you said, essentially we have that positive feedback on Earth thanks to space. And well, there are some times where we waste money by going to space. And there's not much happening, but also it always gives something back. And
Yeah.
maybe Katy Perry wasn't like that. There wasn't huge scientific value of going to space, but we can also think about, well, how many new engineers she inspired by going to space. How many new people got to know that, well, going to space is possible. It's not a crazy dream anymore. It's something that happens on everyday life, and that can inspire new scientists, some of which will go into space science and study space in a bigger detail, but other will go into biology, become doctors, do research on cancer treatment. It's also very important for mankind just to keep the uplifted spirit that we are progressing against humankind, to inspire the youth to do great things, right? To show them that we can progress, we can do crazy things.
Yeah.
And I think that's also a very important part of going to space. Like, yeah, we do spend millions of dollars to send out one rocket. But if through that event we also inspire millions of people, which honestly I do think each space launch inspires more people than a million, that's $1 per person to get inspired and do more for humankind, which I don't think it's that big of a cost.
Yeah. And I mean, it's then again, it's just giving back to humanity. And like, we're always being told that sky is the limit. But like, in the case of space, like, it really isn't. Like, literally and figuratively, it really isn't the limit. And that's just what we're like seeing where the world is headed. Like, it's gonna be a lot more into space now. The youth are moving towards space, and then it's also becoming one of the most popular industries. So that just kind of proves to us that, oh, it is one of the most popular industries now, and that's where a lot of future focus is going to be, because we're already seeing so many new countries that are kind of becoming space nations. Like, India is picking up on the space race. It's not just confined to just US and Russia. We have so many new players. We also have the Middle East setting up its own space centers now, and it's crazy how the entire world is in like going into kind of a unison with this. Like, we're recognizing that, okay, space is important. It could solve not only discoveries in space, but it could also solve so many problems on Earth itself. So it's great to see humanity kind of come together, which is why it's kind of equally important to keep inspiring the youth to enter this field. And that's, I feel like, a really important thing, because in space lies a lot of scope for making humanity progress to new levels. And the more you inspire the next generations of scientists to kind of take to space, we can, hope to make better like progresses, better decisions, make better technologies, and could all over it would benefit humanity. And this is where I'd like to ask you, like, what drove you into aerospace?
Very good question. So I think there are two main things. One, I loved Formula One, like since I was a kid. Like the crazy, cheeky inventions that people could come up to have the edge, especially the aerodynamic part. Crazy. Like I loved seeing that happen. I love seeing the human ingenuity, and just, I always wanted to see like what's the new great thing that they could come up with. And well, you can also say from one, well, say similar to space, right?
Yeah.
Many people think not sustainable, not very useful. I think again fits back into automotive industry quite well. So that was one thing. So I really loved how the flow could be controlled over cars to make them, well, in this case, go faster or produce less drag. And second thing, I really loved looking at stars. I think, well, I loved physics. I loved all things that how they interact, trying to figure out why world behaves the way it does. Like I think that was hugely important. So I had this curiosity. And then something that inspired me further is meeting great people, whether in school, outside, going to science fairs, where you meet people that are similarly minded. You can discuss different ideas. Uh, Listening to podcasts, right, about science, of course. Podcasts that I listened to 10, 15 years ago are different than what I'm listening to now, simply because I'm a different audience than I used to be. Uh, but that certainly helps. Uh, I met a lot of similarly minded people on astronomy camps. That's where I learned to do photos like the one you see in my background. Uh, and essentially, I think that kick started off my drive to space. So I always wanted to study about aerodynamics and things related to, well, off from the ground in general. So aircraft or spacecraft. Uh, and so, yeah, that's how it started. Then it was university. Again, a lot of people who were ambitious wanted to learn more. Some in similar fields, but I also saw a huge value on being exposed to a community that is interested in all of the fields that you can imagine. And so I got very interesting conversation about philosophy, about society, about biology. That when I was in high school, I hated with all my heart. I really got to find the fun in that as well. And there's also a whole field of astrobiology, which is yet another topic. Uh,
Yeah.
then you get to start doing different initiatives. So you can either start your own, like Astra, or you can join an existing one. So I joined another astronomy club that later I became a treasurer of. Then I became a vice president, president. So you also get engaged. Well, also, once you get expertise while you're doing that. So at some points you can also share that expertise, which I find a lot of fun in. So I would say it's a lot that inspired me was talking to people with similar and other interests, because also that allows you to see analogies between different fields, right? As we talked, well, space is really not that different from Earth in terms of, for example, protection of the environment. And I would say talking with people, simply, is that that was what driven me forward, really. And there was always someone asking a really interesting question, and would debate about what's the answer to that question. Like, are there aliens in the universe? Right? A very big question. And then you discuss, you share your views, which already opens your mind a bit. But then you can also go home and try researching, like, well, do we have any evidence of one against the other? So that can really push you forward. You just need to have curiosity. Right now, almost everyone has access to internet, so you have access to absolutely huge amounts of knowledge, including tutorials for beginners. Always there's a video on YouTube or something that you don't understand. So I would say staying curious is what really helps you go through to different
Yeah.
industries, right? But,
100%. Like, especially, like, I'd say in space, the curiosity factor is kind of huge because there's so much we don't know about space. And there's so much that we can keep thinking about and we can stay curious about. And yeah, as you mentioned, the competitive nature of the applications of aerospace engineering. Like, for example, Formula One, the competitive nature, how it kind of appeals to young audiences is also a huge factor because a lot of people my age, including me, we love F1, and that's one of the biggest applications of aerospace that's on Earth. And of course, there's obviously the curiosity factor that you just mentioned. Very important things, really, just to keep the youth inspired and keep them going for space. And it's the way space is booming. I'm finding it kind of more necessary for everyone to kind of learn it, regardless if you want to pursue a career in space or not. It's just there's so much going on in space. It would feel a waste not to know at least some of it. And that's where I want to kind of ask you, like, what's your advice for people to kind of learn about space? Where do they start? Where can youngsters like me develop their interest in space and go beyond?
Yeah, so I would say just follow your your natural curiosity. So different people will be excited about different parts of space. You can be excited what makes galaxies stay in the form of which they are. Why do they keep being disks? And that's a really beautiful thing about space, right? That the galaxy looks the way it does, all the way from nuclear reaction in the stars. So it's really very small scale, right? You're colliding atom with an atom, all the way to whole galaxy working together as a system that is gravitationally bound to each other. Uh, and then you start thinking, oh, so galaxies look like they might be spinning. Do they really spin? How fast do they spin? Right? Ask questions like this, and then it's very easy to go from, well, it's a disk because it's held by a gravity. You go all the way to, well, there must be something else that is dark matter, and then you reach a whole another field of what it actually is dark matter. Right? You can think about, well, is it possible to go to another planet? Right? Planets are also beautiful on through the telescope. Like, then you can start asking, well, how far really is it? What would be life like there? That's how you start learning. And I would say just follow through with it, and don't ever stop asking questions, especially question why. Why are some stars red and why are some are blue? Why are sunsets red? Why is it that when sun sets we see more of red than blue? Even though throughout the day we see blue mostly. We have those things that we see every day, but we rarely even question what we see. It's just so natural. And it applies to, I would say, to space. It's extremely exciting because there's just so many things that need to come together for galaxies to look the way they are. It just, the whole history of the universe, essentially. There's how stars form, how galaxies develop, how they die. It's extremely interesting field. But even on Earth, like, you can go and like ask things like, why is grass green? And then you go into molecular biology, figure out, well, there's a substance called chlorophyll that allows with photosynthesis. Then you get into chemistry. And so I'd say that the most important part is just follow your natural curiosity. Never stop asking why, and just try to find answers. You can start, of course, with the large language models now, which would give you, they will direct you to what you should know. I would advise against learning from large language models because they repeat on what they were trained on, which is not always correct. But they are good at identifying the fields that you should look into. And then you can go on YouTube or any other video platform and ask, like, hey, so what is the chemistry behind photosynthesis? How is it that plants make oxygen and take carbon dioxide in? You can go like, oh, what are those dark parts on the Milky Way? And then just you figure out, well, it seems that this could be dust. All right, where this dust originates from? Why didn't it collapse on stars? Why do we see it as black despite all the other things being very bright? It can it be bright in maybe some other frequency, right? The normal photons are in visible range. Maybe dust is bright in another frequency, and then you get into essentially multi-wavelength astronomy. So I'd say that the most important part is never stop asking questions. And I cannot say, well, the best path is, yeah, you should take quantum physics, then chemistry to figure out how stars work, and so on. It varies from person to person. So I would say just look at what interests you as a person, and just keep learning about this. I'd say that's the most important part on how to find, how to get better in the field that you're interested in.
Yeah. And yeah, I feel like that's a really good point there. Like, never stop asking, especially in a world that, like, everything seems so normalized now. And we forget to ask questions because it is so frequent and it's so natural to us. And that's exactly where we should stop and just ask questions like, why is it like this? So not only in space, but be it any industry, like anyone's interested in, the
Yeah,
very thing keeping your interest alive is your curiosity. And to keep your curiosity alive, never stop asking questions.
yeah, and I would say it's especially difficult now, like especially when you are used to, well, again, society gets in the way. Yeah, with all the apps, TikToks, Reels, and so on, it's so easy to just get in the habit of doom scrolling. Actually, there are channels that provide really valuable information about topics. Like a ton of them, right? There's a whole science YouTube community. And there are shorts that have valuable information, but if you don't stop after that short and you don't ask yourself, well, cool, why? You just proceed to the next short where you are thrown at with another bunch of information that you will later forget. I would say it's very important to be mindful also of your time, and also allowing yourself to be bored a bit. And you're so overstimulated every day. I think that's part of the reason why it's so easy to lose interest, because you're so overstimulated. Like, especially are given answers before you even ask questions, so you'd never really learn asking proper questions. So I'd say sometimes after something that you think is really cool, like, you watch a really cool video, instead of going to another really cool video straight after that, just stop for a second, maybe even take a sheet of paper and a pen and try to come up with just 3 questions that you would have to that video and try to find answers to those questions. It's actually a methodology of one of my college professors. Especially each week, we are asked to read a scientific paper, so just published in a journal, peer-reviewed paper. You didn't need to understand it. You were supposed to ask 3 questions, which is absolutely perfect methodology, because some people had questions like, what is cosine? Because cosine appeared in one of the equations, and they didn't know what cosine was. But some people will be like, all right, in chapter 2, they said that the metallicity of a star increases when the planet is absorbed. But in chapter 5, they say the opposite. Why? And so also, finding a good mentors is important, because then after you find those questions, in this case, if they're really niche ones, you need someone to help you out. But if you just look through a video that's kind of, popularization of science rather than hard physics, if you come up with 3 questions, regardless of how stupid they sound, like they could be really simple questions that you just would like an answer to, or really complex if you understand the topic well. Just try to ask those three questions, and then maybe not straight away, but try to find, well, next day or so on, try to find answers to those questions. Maybe watch another video on that topic. That could be a process of finding the answer. But that way, your process of research is kind of more structuralized and systematic. So you also learn on kind of how to do research, even though it's simple, right? It's just you learning about something, which will also allow you to figure out what you like to learn about. So I think that's also a nice method to stay curious, but also not stay curious in the sense of I overstimulate myself with information, but kind of sense that I get information about what I want to really learn about.
No, that might be the cheat code strat of learning about a topic. That's a very interesting. I haven't heard of it before, but definitely down to give it a try. I feel like that very factor of us asking so many questions would get us to learn a lot more than we would learn without asking those questions. And speaking of answering questions, I feel like we've touched on a lot of topics today, from what is changing in the industry. We've answered some of the biggest shifts in the space industry, also looking at the new technology and even the absurd moonshot ideas that are coming into the space field. And we've also kind of talked about how space can kind of revolve back to society, and finally, advice for the youngsters, why you should take to space or how you can take to any field that you're interested in, regardless it being space or not. The very way that you pick up interest is by keeping your curiosity alive. And we've talked about that too. So I feel like all in all, today's session was very, very productive. I've definitely gotten a lot of more insights than I had before. And it's really been a pleasure having you. Like, what are your thoughts of the podcast?
Yeah, it was great. Thank you very much for having me. It was great to share. As you probably know from our previous interactions, I enjoy sharing my knowledge and tips and tricks on the how to succeed. I'm very happy to be able to share it here, and I hope the listeners enjoyed it as well.
Right. No, thank you so much, Casper, for all that time and all your valuable insights. I think here is where we approach the end of our session. Make sure you guys check out Aerolympics. That's the new startup founded by Mr. Casper himself. Uh, and yeah, just stick to space and stay around for our next session.
Stay curious.